Get a little tiny part 2 here. Okay. So let's try to replace everything. So anywhere I see a y, I'm going to replace it with u negative 1. dy dx, I'll replace it with what we just wrote down. E to the x, and I see y squared, so what's that going to be now? Y is replaced with this, and what's u to the negative 1 squared? U negative 2, I like it. Oh, thanks, Jeff. That was so much better, but can somebody tell me very quickly what's in the wrong place? What's where it shouldn't be? What do I need to get rid of?
The D.
That will actually make everything look so much better. This. Don't I want it to look like that?
Oh, yeah.
What did I just say? And whenever you do this substitution, it's supposed to become linear. Why does it make sense? Because Bernoulli starts off so close to frickin' linear. You would hope that whatever we do makes it linear. So whenever you do a Bernoulli's, whenever you do this weird little substitution, it's going to become linear. Why is it not linear yet? Because they haven't put it in the right form yet. They haven't gotten rid of this stupid thing. So multiply everything by negative u squared, which is really divided by this stupid thing, but just say that. So du dx, now multiply by negative u squared. So what's left here?
1.
U to the first.
Yeah.
And multiply this by negative u squared.
It cancels out.
And get negative e dx. Now in this case, let's see. All right. So how do I attack? So now you kind of adjust your thinking a bit. This whole thing was just to put it into a form that we already know how to do. All right, this was the new stuff. Now this is old stuff, believe it or not. How do I do? This is linear. Is it separable?
Yes.
Just kidding.
No, it's not. Right? Because it's by addition and subtraction. The x and the u stuff. Addition and subtraction, no good. I need multiplication so I could actually separate them, right? Does that make any sense? A little bit? Tiny little bit? Not much? Okay. This is linear. What variable am I looking at to make sure it's linear? U. Linear. I like it. So that will always cause that to happen, which only makes sense. Again, don't just memorize the procedure. Make sure it makes sense why the procedure should work or why something like that should happen. So what do I do here? I look for integrating factor, which is mu. U with the extra leg. E to the integral of what? Poor little thing is dying.
No, this part is U. So U.
What is it in general? What's it in general when I have dy dx plus p of x y equals g of x? E to the integral p of x dx. So what is it? The coefficient of the variable you're interested in. What's the coefficient of the variable? 1.
1. Yeah. Oh.
And I know when you start changing variables, your brain sort of goes, what the hell am I supposed to? You've got to always think back. It's the coefficient of the dependent variable, which in this case is 1. So what's mu? E to the x. That's crazy. So then I get, let me see if you guys remember this. So if I multiply everything by e to the x,
Now part of U to X times U.
this becomes d,
U to X times U.
yeah, e to the x times u. It's always going to be d integrating factor times the dependent variable. Always. You don't believe me, you can just see what is happening. There's the product rule for this, right? When you multiply by this, you create a product rule here. That's why this works. Right? You guys see that? That's how I started when I taught this. I started with a product and did it. So of course when you do this, you end up with a product rule. Equals this. Is everybody cool that side? Oh, what am I missing?
The DX.
Dx. I always forget that. Then you integrate. I'll do this side. Well, that side, come on.
A to E to 2x.
Negative e 2x
Divide by 2.
over 2
Yeah. Plus C.
plus c. And now you just divide by,
E to X.
all right, I'm going, don't let me go too fast. The last few steps here, the minute you get this weird shit done, it should be relatively easy, unless you haven't done any of the linear homework yet, in which case this is really hard. Once you do some of the linear shit, you'll learn to appreciate it. So then I divide by e to the x, so I end up with negative
E to the X.
plus,
C over E to the X.
I like it. Can't just make that c too, because e to the x is not a constant.
That was my question.
Glad I caught you.
Yeah.
Only when you do constant shit to c, right? And u was, what was u? I just took it away. Damn, what was u?
That's Y, like you, Y to me is 1.
Yeah, y negative 1, thank you. So what's the last thing I should do here? And actually, let me do this. So this needs, so put that back there, and then I can just flip it. Is that cool, guys? I can even do that if I want to get all fancy. Whee! Hopefully at this point, those of you who do all the work and not put any C until the end, stop doing that, because that constant can show up anywhere. A family of solutions can have a constant any part of it, any frickin' where. So you got to introduce it at the right time. When's the right time? Well, when you integrate the damn thing, it's when you introduce plus C. And then it just kind of comes for the ride. You can keep it the same and just keep attacking it with shit, or you can keep changing the name of it. All right, let me give you this. I've got two things I want to give you.
Ooh.
Yeah, dude. They're both kind of practice stuff. One of them is, let me just give it to you, and then I'll talk about it. And then it'll be time to leave. So first I'll give you this guy, which focuses on Chapter 2 methods. So I'll have an answer key for this next time, and I'll have an answer key for the practice test, which is the next thing I'll give to you. Just trying to keep everybody here for a minute. Surprised nobody's peeked in the door yet. They're trying to come in. So everybody's got that first hand out almost. Because I want you to understand, the first level of getting Chapter 2 down is understanding each method by itself. The next level of what the test is going to look like is all going to be mixed up, right? Because the next level is identifying when to do the procedures. That's the purpose of this handout here.
That's like when we learn the series and stuff like that, we have a bunch of tests, right? You see a bunch of numbers, you don't know what test to use.
Exactly. It's just like anything. Think about it. Factoring, what would your test look like? All the factoring methods mixed up, right? I mean, it's the same thing. Because that is a huge part of knowing it, is knowing when to do what.
And that's the hard part.
So next time I will have the answer key for the practice test. And it will have an answer key for this. Notice it's got problems on the front and back. And the way this is supposed to work is underneath separable you would put like 1, 2, 4, 5. You just put the numbers that are in that form. And then you try them out using the best method you can see. So that's the two things I'll have answers for next time.
Have a good night.
You too.